Hello, hello. Welcome to this technical stream. We're going to be looking at how to interpret LLMs with Neuronpedia API. Hi, we've got loads of hellos in the chat. Welcome, welcome. I'm going to give it a second for people to join. It's great to see you all heading in. I've got a new microphone, so you're going to have to tell me whether it's good, whether it could be better. Feedback is welcome, you know. I'm going to put some tunes on as well while everyone joins up. Let's get some music going. All right. Audio is clear. Oh, that's so good. Thank you. Wow. Perfect. High praise. All right. I'm vibing with these tunes. A little loud for me, but other than that, they're good. Okay. Awesome stuff. Right. So we're going to get started very soon. We're going to be using Colab mostly. And if you, just a heads up, if you see me looking up here, it's because I've got the chat over here and I've got what I'm going to be sharing down towards the camera. So hopefully most of the time you'll see me looking roughly in your direction, but I'm going to go back and forward a little bit. So I hope that's all good with you all. But yeah, like I said, we're going to be using Colab just because it's nice and easy. We don't have to rely on our own hardware. I'm using a laptop, so that's super helpful for me, and I hope it will be for all of you. I'm going to share my screen, so if you have your laptop up, you've got everything ready, head along to Colab. I'll drop the link in a second, but you can probably just Google it. Let me share my screen. All right. Okay. All right. Hopefully you can all see this now. Let me know if you cannot. Also, let me know if the music's too loud. I can adjust it, or if it's too quiet, you know. All right, so this is the link that we're going to be heading along to get started. And I'll drop it in the chat, and then I'll explain kind of what we're doing today, so that you all have a bit of an idea of where we're going, what direction we're taking. So here's the link. It's in the chat. It's on the screen. Head along here. All right, so we're going to be building actually an AI writing tool. So I think in the description it says thesaurus. It's kind of a thesaurus, but the goal is to have it not just suggest words, right? You know that moment when you're writing and you can't think of the word? Well, it's not just going to suggest the words, but it's also going to show you why the model picked the word, which is, I think, super important when we're using AI to be thinking about like why and what it's suggesting. And this is part of a broader field. It's called mechanistic interpretability. I'm pretty new to it myself, but I've really been enjoying learning about it, so I wanted to run a workshop on it. I'm going to do my best to answer all your questions when they come up, and it's going to be super nice and chillaxed. We're going to take it slow. This is really beginner friendly. All you need to do is have a bit of an understanding of how to write in Python. That would be good. And I think pretty much everything else I'm going to cover, so don't worry. Yeah, we're going to be using GPT-2. You're probably all familiar with ChatGPT, maybe ChatGPT 3.5, 4.0, you might know these different ones. GPT-2 is like, I think it's from 2018, 2019. So it was before GPT-3 caused all of the waves. and became public. The reason that we're using GPT-2 is because it's simpler, it's very small, so it's convenient for our kind of like situation, but also it's open. It's an open model, which means that we can access its hidden states and its different layers and things. And that's how we're going to do the interpretability. So I hope that makes sense. Something like GPT-4 is a closed model, so we cannot access all of its internal workings, which means that unfortunately we can't work out exactly what's going on under the hood. We can have a guess, but we can't do what we're going to do today. And you'll also notice that this stream is called Interpretable LLMs with the Neuronpedia API. Neuronpedia is like Wikipedia, but for features within LLMs. So for GPT-2, some researchers have gone through and labeled all of the different features which you can extract. And they've done that and then put them up into this website called Neuronpedia. And so you can go and search a little feature ID, and it will tell you roughly what it means in human language. One of the problems of LLMs is that when you're looking at all of the internal workings, it kind of is hard to understand, right? And so Neuronpedia is a tool for taking the bits that we can kind of extract from that mess and then labeling them, and then we can work out roughly what they mean from that. I think this is going to become clearer as we go through, so don't worry if it's kind of all being a bit confusing or opaque to you so far. I think it will all become clear. And if you've got questions, throw them in the chat. And also welcome to those who've just joined. I see we've got a couple more people joining. Welcome. No worries at all. So for those who have just joined, we're heading along to Colab. If you want to click the link, I've got it open here. You can see it in the chat as well. And I've just been explaining what we're going to do in this workshop. So don't worry, you're not behind. The summary is we're going to be building a writing assistant tool that not only gives us suggestions, but also we can understand why it's made those suggestions. So we're going to learn a little bit about the inner workings. It's meant to be interpretable. That's the idea. Cool. Okay, so I'm going to get started. You can work along with me. If I'm going too fast, just shout. If you've got questions, just shout. I'm going to keep glancing up at the chat. You can see me doing it all the time. And hopefully we'll build a really cool project. The end goal is to deploy it with Streamlit. So we're going to have this nice little writing interface where we can write in, and as we write, it will come up with suggestions for what the next word should be and why it suggested those. Awesome. Okay, so I've gone to this link, and then we're going to make a new notebook. If you're not familiar with Colab, it's kind of like Jupyter notebooks if you've come across them, but they're not running on your hardware. So you get access to like GPU resources and CPU resources for free. You can pay to have like more resources, but the like free tier, the free limitations are going to be completely fine for what we're doing. So don't worry about that. All right. And if you missed that, I just went to File and clicked New Notebook in Drive. So this will make a notebook just in your Google Drive. So you're going to have to be logged into a Google account. Again, this is free. Don't worry. You don't have to have like billing set up or anything. There's going to be no charges. Okay, cool. And so we've got this notebook. I'm going to name it Neuronpedia Writing App. You can name it whatever you like. Oh, that's not good. There we go. Okay, we've got another question. Why would we use Colab? Oh, there we go. We're going to use Colab just because it means that we don't have to do it on our own hardware. So I'm on a laptop right now. I don't really want to run various different models on my laptop. It wouldn't be very quick. To be honest, what we're doing is actually pretty low in resource usage. So you probably could, just like, especially if you've got like a PC, you could I'm pretty sure you could run it locally. But Colab is great because it's pretty standard. So anyone who, no matter what you're joining on, you can easily use it. Okay, we've got many Twitch ads from 404, and you're in. This is good. This is good. Woohoo for Colab. So true. Okay, so in case anyone else was caught out by the Twitch ads, basically what we're doing, we're building a writing app, and we're going to Colab. That's the summary. Welcome 404. I feel like I should say that 404 joined today in Global Hack Week, which is a stream that I did earlier today, right at the end. So we just missed each other. So I'm sorry for that. But welcome. We're going to get started. It's going to be really fun. So first of all, we're going to have to do some installations. These can be a bit tricky. So these are the things that we're going to install. I've just copied and pasted it in. I'll give you a second to type them out. I'll type out the rest of the stuff that we're doing actually, so we can all type along. I don't go too quick. But we're installing various libraries. This is from Hugging Face, if you've come across them. This is Torch, which is used in deep learning pretty often. SAE Lens, I'll explain when we get to it. Streamlit, maybe you've heard of. This is probably more common than the others. This is a nice tool for building like web apps, basically. I could copy and paste the chat. I could for the shorter commands like this, sure. But I'm not going to, just because when we get to the longer sections of code anyway, they won't format well in the chat. You won't be able to copy and paste them easily, especially with the indentation. You know, we're working in Python. It won't be happy. So I'm not going to do that. The other reason is because when you type it out yourself, you will learn a lot more and you'll remember more. So it's a good practice to type out yourself, and we're going to go at an easy rate to follow, so don't worry about that. Cool. So I'm going to hit enter on this. Well, control enter. This is how you can run cells in Colab. If you're not familiar, control enter. There's also the run button on the left hand side. You can see right now it's running. You can tell even when it's queued, which in my local time is 6:12 p.m. Some other things to notice. This is like your usage up here. You can kind of muck about with the resources and so on. Like it said there, you can upgrade to Colab Pro. If you have issues, you need to reload at some point, you can restart the session here. Those are some options. But right now, we're just doing installations. It's going to do all of that for us. If you're in like a local environment, you know, if you're not using Colab, you might want to set up a virtual environment or use Condo or whatever. So the options are there for you. This is going to take a few seconds, well, maybe a minute or two. So we'll let it run. Like I was saying, sometimes these can clash a little bit. So transformers in particular sometimes is a bit fussy about the version of NumPy that we're using. And Torch as well is a little bit notorious for the version conflicts. So if you have that happen, I will tell you what to do. So don't worry. Probably it will happen to me every time I've like practiced this. I've had an issue. So don't worry. We'll go through all of those. But yeah, it's just installing things at the moment. We don't need to worry too much about what's going on here. But yeah, we're going to use all of these later on. So we're going to do them at the start. Cool. I'm going to make another code block now. You can do this by clicking up here. You can also like hover at the side of each box. The other thing you can do is you can make text boxes. These I think you can type in Markdown as well, or they've got formatting. So if you want to make notes to yourselves as I talk, you can do that too. All right, so while this is building, we're going to do a couple other things. So this is what I normally have had to do with the versions that we've got. I've basically just, every time I've run this, force reinstalled NumPy. And also upgraded. Yeah, so we can see here right now. Woohoo for Streamlit. So true. I love Streamlit. We're going to see how easy Streamlit is to use later. I don't like web dev that much, I'll be honest. So Streamlit is nice. It makes things very smooth. Keep hydrated, by the way. Very important as you hack. 404, saving the day. Are you going to paste all of the code in 404? That might take you some time. Okay, right. And the next, oh, here we go. So the next one that we're going to do here. Sorry about this. My typing today is not so good. Like I was saying earlier, I've got a new headset. I'm actually on my laptop. Normally I'm working. Sorry, we don't need to force reinstall. We'll just do that. I'm actually on my laptop, which is, it doesn't have the normal keyboard, so I'm going to be clunky with my typing. Okay, Python setup.py egg info did not run successfully. That's kind of unusual. I haven't seen that before. So what, I'm going to Google that, and we'll try and work that out together. If we can't solve it quickly, I might move on, and then when we've got a break later, we can come back to it if needs be. Oh, so loads of people are getting the same error. Okay, and it's not this error, because this error we're going to solve in a second. I know what the problem with this one is. Interesting. Everyone's getting the same error. Okay, pip install transformers. Just checking that we've all got the same thing. So it's strange to me that you're getting an error, which I'm not. Let me do some googling. Let me do some googling. And so you're all in Colab, yeah? Make an egg roll and eat it. Okay, so you're all in Colab. Let me check this error out. Okay, so we got Python setup.py. It might be because you're using Colab for the first time, and there's some extra setup that you have to do. I think that's kind of like unlikely, because normally it's so easy to use out of the box. What I'm going to suggest you all do, if you can bear with me, yeah, if you pip install them all one by one, so instead of doing it all together, you can do pip install transformers, and then you can do pip install and so on. You might want to do these in separate cells, like it's predicting here, right? So maybe do this, and then probably it will error on one of them and tell you in particular which installation is the problem. I've accidentally just run this, so that's great. I don't know what to do that. Yeah, okay. But I suspect it's going to be SAE lens. I'm going to just delete this before it starts causing problems for me. I suspect it's SAE lens. This is probably the most unusual library. Okay, it's working for you now. Let me just pop this out in case anyone else is finding this helpful. It's working for you now. Just double check the package names and the spelling on the last bit. Yeah, you don't actually even have to have the quiet bit if you want. It just makes it slightly easier. Okay. Do we uninstall before installing one by one? Yeah, I probably would. You might not have to. We'll get to the next steps in a second. Don't worry. Yes. Yeah, if you want to uninstall and then reinstall, that might be the play. I think just installing them one by one should be okay, though. It should kind of handle it fairly well. Okay. So we've got 404 helping us out here. So this is the command that worked for 404. Super helpful. Thank you. Yeah, so I think this should, in theory, work. If again, I'm thinking I'm going to move on just because I think it's probably a typo issue. So maybe copy 404s and then try again. If you're still having issues, my guess would be that it's SAE lens, and I would suggest in that case Googling an alternative way of installing it than pip. You might have to install it from GitHub directly. But I think that's very unlikely. I've never had that with SAE lens. Never had to do that. So I think you should be okay. Okay. It ran this time. Super cool. Okay, no worries. I think we're just getting to grips with Colab. That's totally fine. Using Colab for the first time, please tell me how to run the second command. So to run anything, you just type in these code boxes. You can make code boxes like this. It's got the shortcut there. I just click it because I can't remember the shortcut. And you can also click down here. And then you just control enter to run the cell, or you can click the play button on the left. Okay, cool. So we're getting the commands running. That's cool. Okay, right. We're gonna keep moving. I had a little error with NumPy. I'm gonna run this prematurely just because I know that with my versions that it sets up, it kind of breaks. You might have to run this as well. Unfortunately, I reran this, but it's a similar error to this actually. This is not going to be a problem because I tested it, and the versions that we've got do actually work. Part of the reason is just that sometimes the various different libraries just don't play too nice. In theory, there are probably like a perfect series of versions that just make it work without all the errors, but for now I've got it working, even though it's putting up a little warning for us. So if you follow exactly what I do, it should be fine for you too. Cool. Okay. Right. Where am I? Let me pull up the little plan again. Okay. So the next thing that I want to do before we go too far. Yes, running shoes for my code. I haven't given them running shoes, I'm afraid, but I'll have to invest for next time, and then they can be even faster. Can you please provide the command again as you are reinstalling it? Not all. Yeah, of course. So if I'm going too quick, thanks. Just shout out. So this is the command that we need. How do you fix the error with NumPy? So this, it looks like it's erroring here, and it is, right? It's claiming that it's incompatible with TensorFlow, and various other bits and pieces are not happy. But for what we're going to use it for, this will actually work. So don't worry, it will actually work. Thanks for Yen for popping those commands down in the chat. Yes, so these are the commands up here. Hopefully we all should be able to like move on with this. If you're having an error from SAE lens like this, maybe you can tell me exactly what the error is. If it's just a dependency like this, pip dependency, then if it's exactly like mine, then we'll just move on because it will be fine, even though it's erroring. Trust me, it will be fine. I believe. So we're going to move on. The next thing to do is actually we're going to go to Neuronpedia. And I'm in the wrong tab, so that's great. So if you go to neuronpedia.org, I'll send this in the chat. Sorry if my stream is a little laggy as well. My laptop is, like I said, not a huge fan of running anything intense at all. So even this is too much, but hopefully it's all okay for you, and the audio and everything is coming through fine. Yes, so I agree with this very much. One of our friendly hackers here is saying that Python dependency conflicts are messy to debug. It's very true. They are notoriously bad with things like PyTorch in particular. Your kind of classic deep learning libraries don't play ball very often. So sometimes there's some troubleshooting, but because I've run these through in advance, hopefully the ones that we're working with should all just be fine. I do love pineapple on pizza, so I'm glad that you wouldn't wish that on me. Thanks for that. Very appreciated. Okay. All right. Yeah, I beat you to this, but here's the link as well. We're going to head along to here, and we're going to create an account. I've actually already got an account. This is the username that it's put for me. And once you've made an account, you can head along to settings and API by doing what I've just done. So that's what we're going to do next. I'll give you a second to make an account. This maybe will take some time. While you're making an account, anyone else who's still having issues with the installations, let me know. And we can work those out while people are making accounts. The reason that we're making an account is because we're going to be using the API. And you can see here, I've already hopped to it. So if you go to settings plus API, it's actually just in the accounts tab. So you can just go to this link. Which I'll post as well, just for ease. I'm not going to show my API key, but this is where you would get it. Hopefully you've been to some API workshops or are familiar with APIs enough to know that sharing your API key publicly is bad, because people may use it and then it will look like you're using it, and they could breach the limits of what are allowed, or it might charge you. In this case, you don't need to pay. It's entirely free. You don't even have to put in bank details. So there's no risk of that. But just in general, keep your API keys secure. Maybe we can have a little thumbs up in chat if you've got to this point. So once you've created an account, head along to this tab, the /account tab, and you're just going to copy your API key. And it will say copy to clipboard like this. Cool. I'm going to chill for a second. I've realized that our music has stopped as well. So while you all are making accounts, I'll get us some music. Let's see what we... Any requests? A little bit of lo-fi maybe? Slow. We got loads of time. We got some thumbs up in chat. That's so good. I'm gonna wait maybe a minute, and then we'll move on. But don't worry, we're taking it pretty slow, so you'll catch up if you're a little behind. In the meantime, we're learning more about pizza cooking ASMR. I don't think I've got any of that on hand. So lo-fi it is. But if we want something, I don't know, more techno or whatever, requests are welcome. Although I can't do particular songs because of copyright, so it's generic vibes that you can suggest, and I will try and find a song that suits. I'm already slightly annoyed by this lo-fi personally, but maybe I'll have to put up with it if everyone loves it. Yeah. Okay, we love the lo-fi apparently. Okay, right. Oh, no worries at all. Go and have some rest. Get some sleep. It's important to take breaks. So no worries there. And you can watch this. It's being recorded. So do not worry. Okay, right. Let's move on. So we've got our API key. We've copied it like this. And we're going to head back to this. And what we can then do is we can go to this secrets tab. And you can see I've already actually put them in. You can just add a new secret. And then you can give it some name. And then you can pop in the actual value. I've already got them in because I was practicing this little workshop earlier. So we don't need to worry about that. At least I don't, but you will. We'll get to ngrok later, so ignore this second one. But for now, we're going to make a secret called Neuronpedia API. You can call it what you like, but that's what I'm calling mine. And you just paste in the value here. That's the API key that you got. And this is going to allow us to access our key without it being public anywhere or without it being in the file. So if you want to share this with someone later, they won't be able to find it, which is really cool and helpful for us. I am going to give us notebook access for these notebooks. This just means that in the notebook we can access this. Cool. All right. I'm going to close this tab out again now, but if you want to find it, if you're catching up, it's just this little key here, key for secrets. Another thing I want to highlight very quickly is because we're in Colab, you've actually got Gemini built in. So if you are finding something particularly tricky and or if you're catching up and you kind of missed something and you're debugging, you can ask Gemini. But I'm here, so maybe ask me first. And if I can't help, then Gemini maybe can. Okay. Right, so hopefully we've got to the point where we've got our API key in the secrets tab. And now we're going to want to access it. Before I do that, I'm actually going to import warnings. And I'm going to do warnings.filter warnings here. And I'm going to ignore them, but I'm only going to ignore user warnings. These are like unimportant. Well, they're important, but they're not critical for what we're doing at the moment. Sometimes they just pop up and take a lot of space, so they're annoying. So I'm just going to ignore them from now on so they don't clutter everything up. You don't have to, but you can if you like. We've got a question. Can I show the API key process again? Yes. So you head along to the Neuronpedia link, which if you scroll back up, you can find it in the chat, and then you copy the API key from here, and then you can close the tab or leave it open, and then you go to this little icon here on the left. You should all have it. It's called Secrets. You click it, and then you click Add a New Secret. And you see that I made one here and left it blank, so I'm going to delete that. But you just add a new one, and you call it whatever you like. I'm going to call mine Neuronpedia API. Just make sure you remember what you call it, because we're going to reference it in a minute. And then you put the API key in here. I'm not going to paste it because I don't want it to show, just in case. But, so hopefully we all caught up on that, which is really cool. I'm hungry. I typed fillet warnings instead of filter warnings. Yeah, I've just eaten dinner, but I don't know what time it is for you all. Make sure you grab some food. I'm gonna change the songs. I know I'm faffing a bit here, but I'm going crazy with the lo-fi. I'm going completely crazy. We've got one called Cozy Coffee House. Should we go for this? Let's do this. Oh yeah. These couple of lines here, just to ignore the warnings. You don't have to do this. This is non-critical. What I'm actually going to do, just in case it's hard to see, I'm going to make everything a little bigger. It's now huge, but hopefully it's easier for you to read and copy things out yourselves. So this is a command. You don't need this one. It's not super important. But if you want to ignore the warnings, you can. And now I'm just typing out the command so that we can get the secret, our API key, from the secrets vault. And so from google.colab, we're going to import user data. Sorry about that. We're going to import user data, and then we're going to say Neuronpedia API key equals, and look, it's worked out for us. Now mine actually isn't called this. Make sure that the thing that you put in here is what you called it here. Okay, so mine is Neuronpedia API, and that's it. So make sure that whatever you call it in there, you put in here. So for me, Neuronpedia API, and print. Okay, and the next thing that we're going to do, okay, because we're working with an LLM, we're going to do a little bit of testing as we go through to make sure that we're actually getting what we want, to make sure our functions are working. So I'm going to define just right here a test prompt. Predicting one for us, we're not going to do that because that's not really what we're trying to do. But ours is going to be the wizard under the ancient. And that obviously doesn't make sense at the moment. The reason is it's missing something at the end, right? So it should be open the ancient book, scroll, or tome, or chest maybe. But basically what we've got is an unfinished sentence. And so the app that we're going to make is going to be helping us, you know, when you can't think of that word, it's going to finish the sentence for us and explain why. So this is our test point. We're going to check if we're getting reasonable predictions throughout making sense. And I'm just going to do test prompt set. Working. Okay. Right, we've got a question from YouTube. How can I have access to the full video? Because this is live, the full video isn't up yet, but it will be. It will be on the MLH YouTube account. You can scroll back. You could search the name of this current stream. Save and search later if you want to watch that forward. I hope that helps. So yes, this is correct. In the parentheses, you have to use the name which you saved. Your secret. Yes. Okay, we've got a request music. We'll switch to that later for sure. Next time we're waiting for something to load or whatever. Okay, so I'm going to run this now. Awesome. Can you load the volume? Yeah, 100%. Sorry about that. I hope that's okay. If that's still too loud, let me know. All right, so this is what we've got so far. I hope you'll manage to keep up roughly. What we've done is we've imported our, retrieved our API key, we've saved it as a constant, and we've also saved a little test prompt as a constant too. Okay, cool. I'm glad the music's okay. Right, so this is good. Now, the next thing that we're going to do is we are going to load GPT-2 and the tokenizer. So the tokenizer is going to be used later, so don't worry if that makes no sense at the moment. Yeah, cool. Okay, so shout if you're still catching up, but I'm going to start typing. Hopefully you'll still be able to see this up here on the screen anyway. We don't want to generate anything. Go away, Gemini. Sorry. Poor Gemini. All right, so we're going to do some importing. You saw we installed some stuff, but we haven't imported them yet. So this is going to be where all our imports come in. Ooh. We're going to import torch. We're going to import transformers. Well, from transformers, we're going to import some things. And it's actually worked out those correctly, which is neat. Yeah. These are also correct, but we'll get to those in a second, so don't worry about those. From SAE lens, we're going to import SAE. All right. And then we're going to import requests as well, which is how we're going to query the API. All right, cool. So we've got our little imports here. This is, I think, all of the imports, at least for now. There may be some later. Actually, there are some later. I accidentally ran this, so it's errored. Don't worry about this. I don't even know what this error is. We're going to just ignore that. Oh, it's erroring on here. Generated code may be subject to a license. It's taking the code from somewhere else. Thanks, Gemini. Weird that it's erroring on this, though. I'm going to delete this and just rerun and see what happens. Okay, we're definitely getting an error. This is looking like we might have some dependency problems. Okay. It's not ideal. Let me just double check. What's going on here? Just gonna... Yeah, that is definitely the right command. Okay. Yeah, so this I think is going to be an issue with these up here. What I'm actually going to do is I'm going to just rerun all of these because I think I accidentally ran one of them in the middle, which maybe broke what I'd already done. So I'm going to just do it again from scratch. I'm just going to rerun the whole lot. Actually, no, I know what it is. I think I know what it is. Yeah. Okay, so I'm going to rerun these just to make sure that it's all freshly installed. And then I'm going to restart the runtime, which is kind of just like restarting the kernel. Yeah, so this is fine. This is kind of what I'm expecting. It's ran. So I'm going to go to runtime. You might have to do this as well. And I'm going to do restart session. And it's going to say we're going to lose all the local variables. That's okay. All right. Okay, and now if I just give this a quick run, we shouldn't get any problems. I really hope. I really hope. We'll give it a second. Okay, we got a question. So, oh, this is good actually. It's past the import that was erroring. How do I get the API key? If you head along to Neuronpedia and scroll up, or scroll up in the chat, the link is there, and then make an account, you can just copy one here, and then you can pop it in your secrets tab. What did I do to resolve the last error? So I ran the commands that we'd already done again, which think they've got problems. They don't really. They think they do. They do, but we're not going to worry. And then I restarted the session. So you go to runtime, you click restart session. So the key thing is running these two commands and then restarting the session. The reason for that is this one fixes this error. So this error is a problem. And this error is not. So we run this to fix the NumPy clash, and then we restart. If you click on the first command and it doesn't display anything, is it working? Yeah. Sometimes it just, if it's already got everything installed, sometimes it will just run and not say anything. So don't worry. Yeah. The key thing is that you can get these imports to work. If these imports work, then everything is fine. I'm actually going to rerun the cell above as well. You might have to do this if you restart your runtime, just because otherwise it might have forgotten these variables here. Cool. Okay. Right. Awesome. So these are our imports. And now we're going to, you saw a sneak peek of it earlier. I'm going to load the tokenizer and model. All right. So this is, tokenizer just takes all of the natural language that we've got. So, you know, our prompt, for example, and puts it into tokens. Tokens are just like big vectors that the model can understand. Am I able to share my notebook? Good question. I can probably share view access. Yes. Let's give that a go. All right. Yeah, that should be fine. Anyone with the link can view. Yeah, okay, cool. So I'm going to pop that in the chat. That's a good question. Thank you. All right. So if you head along to that link, you can view my notebook too. No problem. Yeah, I hope that's helpful. You should be able to see it live updating. You might have to refresh it as I code. I'm not 100% sure. I haven't like shared a notebook live before, only after the fact. But yeah, at minimum, when I'm done, I can reshare it and you'll have full access. You can copy and paste to your heart's desire. I also wanted to just flag that if you haven't checked in, you should check in. The check-in link is like way up in the chat. I'll probably pop it up later on as well. But by checking in, you get points. Make sure you get your points. Points are good. We love points. So do that. All right. So, okay, I'm going to get moving because I think we've got about an hour and 10 minutes left. And I want to make sure that we get through this because it's a really satisfying app in the end. I'm really proud of it. So we are loading an auto tokenizer, which basically just takes all of the natural language, the English, or probably any language. Actually, that said, I think GPT-2 is only trained on English. You could Google that and check. I'm not 100% sure. So if you want to use it in a different language, you'd have to, well, you could just try it out, to be honest. You don't have to Google it. You can also just change the prompt that we set earlier to whatever language you like, and it might just break. It might get very confused. I'm almost certain that it's only trained on English. So this is GPT-2 small that we're using. And at the moment, I'm just loading all of the pre-trained models and tokenizers, which we're going to use later. The reason that we're using small is because, like I said earlier, it's open source and it runs really easily, and that's nice because we want our app to run smoothly when we deploy it. And this line here, so this is the model that we're loading. This is GPT-2. So we're not loading it to train it. So this is why. This is what this means. This is a tokenizer, which means that our prompt will be put into tokens, which you can understand. And by outputting the hidden states, we're essentially telling the model to return the internal representations. This is how we're going to see inside GPT-2. We've got a couple more bits and pieces to type out here. So These are, we're going to set the device to CUDA, which is just like use the GPU basically. I think actually though that this will run kind of fine. Yeah, that's actually correct. This isn't, we don't want this. But yeah, it should probably run fine on the CPU as well. Actually not 100% sure. I don't think it makes a massive difference for this case. So don't worry about that. Okay, right. So I'm going to rerun this. It's going to load all of the different models and tokenizers and settings that we want. But yeah, what I'm doing here is I'm saying, okay, if you can use the GPU, otherwise use the CPU. This is our Python logic. And then I'm taking the model and I'm saying, use that device whenever you do anything. And I'm going to run this and it's all going to be beautiful. All right. It's loading everything. Cool. All right, that's good news. That's good news for us. And I think, oh, I misspelled causal. Did I? I think I'm okay here. It's, oh yeah, you might be, okay, yeah. So it's definitely causal and not casual. Make sure that you get that right. I'm very confident that we're good here. Or did I misspell it the first time? Because I remember I had an error. Maybe you're telling me about that earlier. But I think we want to test that this is actually loaded correctly. This is kind of where we start to get onto the fun stuff. So far, we've just been doing very boring setup. No, you're good. Don't worry. Don't worry. No need to apologize. So what I'm going to do is we're going to take the input IDs, which is, it's kind of worked out here pretty nicely for us. We don't want this, which, well, we do later. This is just pulling through all of the IDs in, like, it's basically tokenizing it, right? And I'm going to go through all of this terminology in a second, but I'm just going to finish writing this and show that we've got it working, and then I'll go through what it all means. So, attention mask, tokenizer, and we're going to use our test prompt again. And we're going to say return tensors equals, I know it's predicting for me and it's predicting fairly well, but I'm actually going to keep typing out just because then it's easier for all of you to keep up. I don't want to go too fast. So this is good for us. Again, these are just, again, like some setup bits and pieces. I'll talk through all of this in a minute. So we're going to explicitly set what's called a pad token ID. This is, again, like some setup. I'm not really going to go into the details on some of this just because it's kind of like not really needed. But basically what would happen if we didn't set this is it would go, oh, you haven't set this ID, and it will just set it for us. So it's not that important, to be honest, but I'm doing it just to avoid the warning. So now we're going to generate some text. And now it's getting to the bit which it predicted earlier, which is neat. It's got to be said that, are we tabbing twice at the moment? What are we doing? Yeah, we've been tabbing twice, okay. Make sure you get your indentation right, otherwise you'll have problems. So now we're getting to the fun stuff, basically. Input IDs, so we're taking the input IDs. So these are the little bits of setup that we did earlier. Oh, hello. Why have you done that? Sorry, everyone, I don't know what's going on there. My, like I said earlier, I'm a little bit laggy on this device, so apologies, and please bear with me if little bugs like that happen. I don't know quite what happened there. Cool, and then we need to set the max length. This is the max length for the output that we're going to generate. Okay, we got a little question here. No problem. So for the side we just did, I'm getting runtime errors and attribute errors. I double checked. I have the exact same code as yours. Was that here? My suggestion would be that if you're getting... Is anyone else getting those errors? My suggestion would be that probably what you need to do is reinstall these and restart the runtime. Oh, multiple people getting the same error. Okay. Yeah, I think the only thing that is really going to help you out here is make sure that you've got your installations correct, because so far all of this is like very textbook. Like this is just straight from the docs. You copied the exact same code from the Colab, still getting errors. Okay. What I'm going to suggest you do, either send me the full error and I can see if I can help you debug that, or run this command, then run this second command. So run the full installations, run the forced reinstall, and then restart your session. This should resolve the installation errors. And then when you do your imports, it should all work. And all of this is just like, as long as you've got your imports correct, this will work. This will 100% work. If you tell me like which line that it's throwing your error for, and what the error is exactly, I can try and help you more. But without that, I don't really think I can. So give that a go, and then tell me how it goes. In the meantime, I'm going to keep typing slowly on, so we can make sure that we finish in time. I'm wary that we are... What is the time? Okay, we've been streaming for about 50 minutes, so we've got about an hour left. What I'm doing here is I'm setting the max length to be the length of the input IDs, which is how it's tokenized it, which is like, this is just pulling out the length of it, basically, because it's turned it into a tensor. And then I'm adding 1 because I only wanted to generate 1 word. We could have it as, we could just set it as like 10. I'll show that in a second. And then we'll work through that. We've got another question. What did you do for the pip dependency resolver error? So these errors up here, this one is completely fine. We just ignore this. It's having a paddy, but it's okay. The key thing to do is run the first set of installations and run the second set of installations and then restart your runtime. If you do all of that, I can guarantee that it will work exactly, as long as you've got exactly the same code as me and you do exactly those steps, because it's working for me. And other than that, there's no hardware difference because we're all on Colab, which is the nice thing about Colab. Okay, right. So we have set our output here. We're going to generate our output. We've set our length. That's good. And then we need to decode this. So we're going to say that the generated text. Ooh, again, watch out for the indentations. Killer these are. And we're going to, let me get that right, dot decode, and we want the output like this. All right, and, oh, sorry about that, that's Gemini causing problems for me. I should probably turn Gemini off in this notebook just for ease, but I can't remember how to do that. So for now, we're just gonna keep plowing on. And we're gonna say prompt plus generated text. And then we're going to print it, and hopefully I'm going to run this and it's going to work. Awesome. Oh, this is so cool. So you will see that this is the prompt that we set earlier. So if I scroll up a little bit, I'm going to hide this long output so that we've got less on our screen. So this is the prompt that we set. The wizard opened the ancient blank, right? We didn't finish the sentence. The wizard opened the ancient something. And down here, it predicted book. Right, you can see that we generated an extra word, which is this +1 on the normal input, and that word is book. Whoa, it probably had other predictions as well, so we'll get to that in a second. If we wanted it to predict like 3, we could rerun this, and it will predict like 3. The wizard opened the ancient book and read. Yeah, cool. So it's helping us with our writing already, and later we're going to get this into a nice little flashy app. But already we're generating text, which is really cool. Cool. So just as a little summary, you can ask me questions about technical details, but I've been using some words which maybe you're not familiar with. I'm going to go through some of them now. The one that probably has come up the most so far is token. A token is just a chunk of text. or a word or part of a word sometimes. Some other things to be aware of. I mentioned hidden layers earlier, well, hidden states, and layers. Layers are like a processing step inside a neural network. Had some power issues. That's so unlucky. They're trying to stop you from learning about Neuronpedia API. They don't want you to, they don't want you to understand the inner workings of AI. You'd be too powerful. You'd be too powerful. No, okay. Yeah. If you scroll back up, anyone who's trying to catch up, I've shared access to my notebook, so you can view it and code along with me. You're getting an error from the transformers auto tokenizer line. Yeah, so that's almost certainly your installations. You need to restart your session. So go up to runtime and restart your session. Cool, okay. Awesome. All right, so the goal of what we're gonna do now that we've got somewhere is we're gonna generate the next word. So instead of 3, we're gonna do just +1. And we're gonna produce a little explanation of how it's predicted that word, what the model has been thinking about. And the way that we're going to do that is we're going to take the penultimate layer, the layer that's second to the end, just before it predicts the word, and we're going to examine its hidden states and try and extract the features. So the features are kind of like directions in the internal space within the model, and they represent something. So they might represent a concept like freedom or anarchy, or they might represent something like nature, right? They could represent many things. So we've got a question, well, not a question, but it's just a little fact here. Yes, so rerunning the same block, you get the same next word. Yes, it's deterministic at the moment. So there's no variation. When you're using ChatGPT or something, they have some element of introduced variation, randomness, variability. The model that we're using doesn't, but we will see that there are other options for the words that it will predict, and we'll display those too. So yeah, it is very interesting. All right, okay, so I think we've got most of that down. The key thing is features are going to convey the kind of concept that the model is thinking about, and we're going to try and extract those concepts just before it predicts the word. So in this case, book, just before it predicts book, we're going to say, oh, what is it thinking about? This is not like perfect, but it's kind of, we're trying to get an idea, right? And Neuronpedia is going to be the tool that takes the feature and labels it in human language. So the feature, it might just be some like ID, but we're going to get it into English, which is handy for us. Oh yeah, one other thing I thought to mention, activations. When I say, a feature's activation, it's a value which shows how strongly the model believes that concept is active. So if we are, I don't know, if it's looking at some text about liberty and rights and human laws around freedom, it might say, yes, the activation for that feature, the freedom feature, is very strong. That's kind of what we're hoping. Cool. All right, neat. The final thing that I want to cover before we move on to the next section, and then we will get to more code, don't worry, is what is an SAE. So you will have noticed right up at the top that we have installed this library called SAE Lens. SAE stands for Sparse Autoencoder. It's kind of like a translator. It turns some high-dimensional model activations into something sparser, right? And hopefully something which we can extract meaning from, i.e. human-readable features is the goal. In this case, we've got one for GPT-2. This is a model, it's a neural network, which someone else has trained. We're going to be using a pre-trained one. And it's going to project all of the stuff inside GPT-2, the hidden states. It's going to try and project them onto 3,000 different features, ideally such that only a couple activate at once. This is what we call sparse. They should be 3,000 sparse directions. They should be distinct from each other in some way, so that when we have some text, most activations are near 0, so that we've only got a couple which activate, and then we can analyze them a bit at a time. So kind of like dividing and conquering in a sense. And this is useful because GPT-2's internals and all LLMs internals are like a wrangled mess to us. We cannot understand them. But an SAE is like pretty cutting edge research that is theorized, and definitely in this case, it's going to help us understand what's actually going on. So that's the theory. Don't worry if that's all a little bit confusing. It hopefully will become clear as we start to write some more code. All right, so we want to write something that's going to, instead of just predicting one word, let's say we want a couple of different words to pick between. And maybe we want to know the probability of how likely the model thinks it is that those are the next word. So we're going to write a function to do this. This is going to be like a slightly longer function, but it's kind of important for what we're doing later. So I'm going to get started with it. And it's going to take in as an input our prompt text. And it's going to get the top K tokens, i.e. the top K kind of predictions. Remember, a token is kind of just like an encoded bit of language broken down into chunks for us. And K is going to be the number of predictions that we're going to get. So we're going to get 3. You probably should like document your code, you document your functions and things, but I'm not gonna, for the sake of time. Sorry, this might not be the prettiest and most readable code in the universe, but it will work, and we will get a lovely app. So we like that. All right, so you'll recognize this. We did this earlier when we made a prediction, and basically what we're doing is we're rewriting what we've already written, but in a function and slightly more flexibly, so that we can, that's actually correct, so I'm just going to copy that out, slightly more flexibly so we can predict multiple. And now we're going to get the logits. The logits are internal to the model, and this is what we want. Cool. Okay. These are the logits. I'm going to just pause for a second because I think I've gone quite quickly there. Feel free to throw any questions in the chat while I'm paused. Happy to take questions. I'm going to take a drink of water as well. Like I said earlier, keep hydrated. Make sure you've got snacks. I love a good snack while I hag, you know. It even rhymes, so it's kind of meant to be. Okay. Nice. I'm going to keep moving now. So what we've done is we've got the logits, and these are kind of just like a score associated with all of the words that the model thinks could be the next output, or rather more all of the tokens. These are unnormalized, which means that unlike a probability, they don't add up to 100%. They don't add up to 1. They're just kind of scores, right? They're relative to each other. But we're going to want to normalize them at some point. What we're actually going to do though first is we're going to get the next token logits, which is basically just the scores for the next token, i.e. the next word. Awesome. Okay. Right. And this comes just from the shape of the logit. Yeah. Cool. Now, like I said, these are unnormalized, but we kind of want probabilities really here. I'm actually gonna like unindent this as well. I don't need that like that. Yeah. Cool. All right. Give me a little wave in the chat if you're still following along. Let me know if you've got questions and things. I'm happy to go slower or faster if it's not quite your pace. And now what we're doing, so like I said earlier, we've got these logits, but they're not actually probabilities. So we're using what's called softmax, which is basically just like a little function that's going to help us get them as probabilities. And it's worked that out nicely for us. That line is perfect. This line is not. So I'm going to delete this down. What actually we want here is the top k probs and the top k indices is going to be equal to torch.top k probabilities and then k. We don't need the extra k. I don't know why I wanted that. Okay, right. So what we're grabbing is we're grabbing the top k probabilities and top k indices, basically the indices for the top tokens, the best matches, best suggestions, and we're getting the probabilities that are associated with them. We are going to now get the tokens using the indices. So I'm going to make a little empty list, which again is formatted slightly weirdly because my laptop's struggling. So for the index probability in top k indices, top k probs, yeah, that's good. We're going to set the token text to tokenizer. Actually, what we want in here, sorry, causing problems, because these are not lists by default, and otherwise it's going to have all sorts of tantrums over that. And then I'm going to decode all of these. Okay, right, that's not great. There we go. Nice. And then we're going to get a nice little function finished. Now this has no comments, no documentation. It might not make much sense. What I might do at the end is I've got like a fully finished notebook, which has got all of the comments in. So I'll share that. And then you can kind of like read some of the explanations on your own. But for now, this is done. And it runs. It would be weird if it didn't run because it's just defining a function. But now we're going to test it. So let's try. We're going to say we want to get the suggestions, and we're going to use our function. So that's get top, what did I call it? Top k tokens, yes. And we're going to use the test prompt, and we're going to say 3. And then we're going to print, actually, we don't want to print that directly. I'm going to print prompt. Test prompt, and then the suggestions. Let's give that a go. Nice. Okay, so it's not formatted these particularly nicely. You don't have to do this. I've got some nice little formatting that I'm just gonna copy and paste in here. You can do it if you wish. These are weird because of where I've copied them from. So yeah, it's not happy about that. I use Obsidian for all of my notes. So okay, so what I've done is I've taken what we just printed out anyway. You could just print suggestions directly, and I've formatted it nicely. I've taken the probabilities and multiplied them out to get the actual value as a percentage, because by default it's just a decimal. So you can see it's predicted book as the top one, which I think Mahendra said, yep, in the chat. Oh, you always get the same word. Everyone will, because it's deterministic, like I said, but the probability associated with book for this model is 10% given our prompt, right? You've got door, which is slightly lower, scroll. These are all kind of things that we'd expect. The ancient door, the ancient scroll, the ancient book. This is good. This is good. And nice, our function is working. Cool. Nice. Okay, so this is good, but now we're only getting the words and the probabilities. We're not actually getting an intuition for the concepts behind why it's decided using our prompt to predict these words. Because presumably it's gone, oh, book, scroll, door, those things can be ancient. probably in the data that it's trained on, it sees those words together the most. But it's learned some connection there, and we want to try and work out what that connection is. So that's the goal. And like I said earlier, the way that we're going to do that is with sparse autoencoders. So now we're moving on to the next little section. We're going to load the sparse autoencoder for GPT-2. This is GPT-2 small in particular. And these might look a little bit alien. Chunks of these maybe we won't use, but we need the SAE. So we're going to, this is from the SAE lens library that we've already imported a little bit further up. So if that didn't work for you, now is the time to fix it. Awesome. Okay, cool. And I'm actually going to take a new line here and say release. I don't know why it's having a paddy here. Am I in like a text block or something by accident? I don't think that's right. I'm gonna. Okay, it was trying to run. That was why it was trying to run. Collab sometimes causes chaos. Fine, we'll just do it again. All right. Cool stuff. Okay, so like I said, we're going to load the pre-trained SAE. So sparsity is this idea which I spoke about earlier, which is how different are the directions from each other. So, for example, when you have trained, a model like GPT-2, it might have cleverly used the same neuron to express cat and, I don't know, cake or something at the same time. And we're trying to disentangle basically all of the times where it's got concepts kind of messed up together, which it's using effectively, like right, clearly it's predicting the right things, but it's not clear to us. It's clear to the model, but not clear to us. So we're going to disentangle them with an SAE, which is really cool. I am defining some things here. Again, like I said, these might seem a bit alien. But basically, I'm configuring the SAE model that we want. I've got a particular one that I've picked out. I think this one is from Anthropic. I'm pretty sure it is. Just going to make sure that that is formatted. This is the right data type. Cool. Okay. Nice. So just to quickly explain, we're using GPT-2 small, like I said. This is like a residual, excuse me, sorry, a residual SAE by a guy called James Bloom or something, I want to say, JB. If you Google this little phrase, in fact, this whole section, if you like, it will come up and you can read more about it. It's on Hugging Face, I think. I can link some of these resources later if that's helpful. And I've selected, so like I said, we were talking about all of these layers. This is the 11th layer. So there are 12 in this model. This is the penultimate one, the one just before it does its predictions. I've chosen that because I think probably it will give us the best kind of like concepts. You could have an experiment. You could try different layers. You could try 7. You could try 1. It's going to be learning slightly different things at each layer. And there like is lots of research that goes into this in academia about like how we can best interpret things. All right, and we're going to make sure, first of all, before we keep going with actual functions that we're going to write for our little app, we're going to make sure that we've got our SAE on the right device. Like I said, this is just like the GPT model that we moved to the right device earlier. And we're going to make sure it's in evaluation mode. This just means that it's not going to try and train or anything. I don't think it would anyway, to be honest. I don't think that's necessarily needed. I'm just going to write like SAE loaded. All right, and hopefully this is going to play ball. So we're going to basically trying to extract meaningful sparse directions, right? This idea of like in the internal space from the hidden states, the ones that are unintelligible to us as people. They don't make sense to us. They're not in English or anything like that. We're going to try and extract these like specific features using this model. Nice. Okay. I haven't had any questions in a while, so I'm kind of assuming I'm just going to keep moving. But stop me if you have any questions. So, all right. Big moment. We're now going to go and write a new function. And this function is where we're going to pass the hidden state from this 11th layer through the SAE that we've just loaded to get the sparse activations. And then we're going to extract the top K features, just like we picked the top K predictions. So 3, we might extract the top 3 features that have the strongest activations, i.e. the model, the SAE has thought these are the most related to the prompt according to GPT-2, which it's trying to interpret for us. So let's write our function, and it will all become clear. We're going to call it get features, and again, it's going to take our prompt text, and we're going to take in some number of features that we want to get. In this case, I've just said 3, and the first step is going to be we're going to run the prompt through the model to get the hidden states. So this is kind of like what we've already done. And again, like lots of this is going to be like fairly familiar now. This is actually exactly the same as a line that we've written twice already. It's getting, that's not right. It's getting those inputs in nice token form to feed into our model. That's not what we want at all, actually. So I don't know why it replaced that. All right, I'm going to indent this again because it's freaking me out. And then again, we're going to do this little line with torch and a grad, which basically means don't try and update, don't try and train, don't calculate the gradients. If you're not familiar with gradients and how models train using them, I'm actually not going to go over it now because that's a whole other can of worms. But I recommend you look into some basic courses on deep learning. If you go to the PyTorch website, they've got some really great tutorials if you are completely new to neural networks and things like that. Okay, cool. So we have grabbed the hidden states. This is a list of 13 tensors. So that's because this model has 12 layers. And the 0th tensor is embeddings from the prompt. So cool. So that's step 1, running the prompt through the model. Step 2 is going to be grabbing the hidden state just before it does all the predictions. So that's layer 11, and we're going to say, right, okay, well, residual pre 11 is going to be the hidden states for the 11th layer. So this is we're just grabbing the states at the 11th layer, right? And then we are saying, okay, let's grab the final token activation, which is kind of like, what is it thinking about in that moment? How is it handling the prompt at this point? So at this point, it's gone through, well, it's in the 11th stage of thinking, if you like, reasoning, or maths is what it really is. It's kind of just adding little bits of bias and multiplying the input tokens that we give it. That's what's actually happening internally. So it's done all of its kind of conceptualizing, hopefully, and we might get something useful here. And now we're going to encode this activation that we have extracted. So we're going to say, okay, sparse activations, which are the ones that are going to be interpretable. We're going to encode there we go. And the final, no, we've already done that. Sorry, losing track of where I am. Okay, right. So we've got the sparse activations, and we're going to have to do some, it's it's not actually worked out. Never mind, I'm going to ignore that. We're going to have to do some wrangling. So we're going to squeeze them. What we're doing right now is we're just kind of reshaping them, moving them to the CPU, because that's what we need to get them using NumPy, which is what we need to sort them. And the shape at this point is just the number of features. I'm going to just indent these again so I'm consistent. Okay, cool. So if you're not familiar with this kind of thing, I recommend a PyTorch tutorial. Squeezing is something we do to change the shape of our tensors, and tensors are kind of like arrays. But yeah, I recommend learning about this if you don't know about it already. It's super interesting, and I think that's actually all correct. So I might just tab that. So what we're doing here is we're getting the top feature indices by sorting our little NumPy array. This I don't think is how I'm going to do it. What I'm going to do though, yes. So right now we are extracting the top K, like you can see here, top K, which is going to be 3 in this case, features by activation, top K activated features, if you like. And I'm going to reformat them. And the reason that I'm going to do this is because to use Neuronpedia, which is kind of where we're really kind of ending up, where we're getting to. We need to have them in a certain format, and the format. So I'm just making a list here, by the way. The format is going to be as follows. It's going to be GPT2-small/11 res-JB, and then it's going to be / and then just the index. This, you probably recognize, this is the model that we've been using, and this is the layer and SAE combination. This is the standard format that Neuronpedia uses. You can check out their docs. We've already got the API key from them, so you already have the website. This is actually not correct, so I'm going to retype that. But yeah, basically we're just getting into the right format so we can say, okay, we've got a feature which we've got the index of. Can you tell us about it? And this is now our function, and we're going to run it, and it's going to work because we're just defining it. So this is the real moment of truth. We're going to test it out. We're going to get the features from our test prompt. I'm going to say k equals, let's say k equals 5, just for fun, and then just print them. I'm not going to bother reformatting them. Okay, cool. Right. Oh, little pause. I might let you all catch up for a second. How much time do we have left? Okay. Got about half an hour. I think that's plenty of time. Awesome stuff. Okay, any questions right now? Give me like a little confused face, a little confused emoji. I assume you can do confused emojis on Twitch. You can do an emoticon, a little sad face if you like. I hope you're not sad though. But if you are confused, let me know and I'll pause. Awesome stuff. Okay, really great. So what we've got is these formatted features, which is decided, based on our prompt, are the most likely ones. And we could take these to the website now and go and try and work them out. I can't remember exactly where it would be. It will be somewhere in here. But we're not going to do that. We're going to use the API because it's API week and we want to use it in our app. And we can't just hop onto the website and get them manually, can we? But the good news is, yes, we've got features. We've got 5 features for our prompt, which we've kind of interpreted using an SAE on GPT-2. Nice. Okay. Now, these might correspond to loads of different things. Like I said earlier, it could be freedom, it could be nature, it could be something like technology, it could be much more specific. It could be, sometimes lots of them are like actions. So someone giving someone something might be It'd probably be worded better than that, but that's the kind of thing. Awesome. Cool. Okay, so, right. As a little summary, what we've done is we have gone from actually, I'm going to pull through my notes. Hopefully you'll just be able to see them. Because I've got a nice little diagram, and I think that's going to be helpful. Yeah, okay. So, like I said, we've got features, and they might correspond to different things. So the examples that I've put here are... okay, I've gone all the way up. I might share these notes with the crowd as well if they're going to be useful to you. This is a little diagram which I've sketched up, which I think is going to explain what we're doing. So we've got the prompt, we're putting it into ChatGPT-2, and then we're doing two things. We're getting the logits for the next word, which are just scores on which word is more likely, or token. And then we're using softmax to get the probabilities, and then we're getting the top tokens out. That's for the predictions. That's for the the kind of predictive text, if you like. The other thing that we're doing is we are taking the hidden state at layer 11 and we're feeding it into an SAE, a sparse autoencoder, and it's taking all of the activations and kind of like spreading them out into nice little directions that make sense and hopefully activate sparsely. They activate, you don't have like hundreds activating all at once. And this is going to get us the top features, hopefully fairly reliably. Cool. Okay. So I'm back in here. I'm going to move this out of the way. Nice. Okay. Awesome. So really cool. Let's try and call the Neuronpedia API. And I'm going to type this out. If we start getting close to time, I'll start copying and pasting so that you can copy and paste from me. But I'm going to type out for now because I think we still got time. So we're going to need to get the right headers in place. This is for authorization, and this is where our API key is going to go. This is going to be the format that we want, just like that. Hopefully some of this is a little bit more familiar if you are into your kind of web dev and APIs already. You maybe are like a little bit more confident on this stage. And now I'm actually going to copy and paste this because it's a link. I'm going to send it in the chat. Have you just had your power go out as well? This is so unlucky. Feel free to check out the notebook and just catch up that way. So this is let me just send it in the chat. Yeah, so this is the link that we're going to type in here. I'm going to copy and paste it. I recommend you do too, because if you get something slightly wrong here, it's going to break and throw an error. And actually, your power is back and you come back the time Mahendra's power goes out. This is so unlucky. This is really unlucky. The good news is you can control C, control V. You caught up already. This is good news. I'm so glad for that. All right, what's going on here? This is not looking right. There we go. Okay, so what I'm doing here is I'm saying, let's try just the first one that we've got here, the first feature in our little list, and let's just do like a dummy little query to see if we can get the API working. There is documentation for this API. The documentation, transparently, is not great. I think they are working on it a lot. It's very new, and it's also the only API that I know of for mechanistic interpretability, which, like I said earlier, let's actually say not 200, and then we will print. Yeah, what was I saying? So yeah, this is the only API for mechanistic interpretability, which is this kind of study and idea of trying to understand neural networks, and specifically at the moment, LLMs. So if you want to read more about this kind of thing, you can search mechanistic interpretability. Neil Nanda is one of the prominent figures in industry. He works for Google DeepMind. He's got some really great beginner resources So I would suggest you check them out if you want to learn more. And yeah, check out the docs if you want to learn more about this API. But like I said, it's not a particularly friendly API. Can't find that page. Yes, so do not. Yeah, that little link there is to go in your code. Don't worry, you don't have to click that. You don't need to go anywhere right now. Just copy and paste it. It is this bit here. If you're looking at my stream right now, I just didn't want you all to have to type it out for anyone who wasn't directly viewing my notebook. But yeah, don't worry, you don't have to go to that link. If you want to go to the API docs, you can click here. No, see, sorry, you're fine, you're fine. I love the little robot face that Twitch does, by the way. Is it just me who loves that? I'm such a fan. Okay, right, so where are we? Yeah, this is Neuronpedia's API. We're going to be using the get feature. There is like a ton of other things that you can do, as you can see. Some of them are like more or less easy to use. Search, so you might look at this and think, top features for text. That's what we're doing, but we're doing it manually. Why are we doing it manually, Quinn? The reason is because for whatever reason, I'm not entirely sure, theirs uses a slightly strange method, and it doesn't actually get the results that if you do it, yourself through the SAE. It doesn't get you the same feature activations. Theirs are kind of just wrong. I think it's because of the filler words that it uses. I think it doesn't like the, for example, the stop words, and it gets all sorts of confused. So the way that we're doing it is actually going to be more interpretable for our use case. You could have a play around with theirs. I had a long play around with theirs. I had a really good try, but I couldn't really get it to do what I was kind of hoping for. That is, I couldn't get it to actually put out features which represented what the model was kind of considering, at least from my perspective. It kind of started rambling on about US policy and features relating to laws and things which were not relevant to our wizard prompt that we've been testing on. So where have we got to? We've got this JSON. The JSON is gross. You can see it's long. You can download this if you want. I'm not going to. We're going to write another function instead, which is going to do all of the formatting for us. How much time have we got? Yeah, I think we'll write this, and then when we get to the Streamlit code, I'm just going to copy and paste this. And the reason is because the Streamlit code is interesting, but not as, I'm not doing a Streamlit workshop here. So I want to kind of focus on this. So this is going to take in a feature ID, and it's going to take in, which is an integer, and it's going to take in the model, which is GPT-2 small, and it's going to take in the layer, which is that. Awesome. Okay, and we're going to set the headers. This is all correct, so I'm just going to tab on that. We've already done this. Now, let me have a think for a second. I think because of how we're extracting features, we don't need to do this. Let me go and double check what I've done in the past. Yeah, we don't need to do this. Oh, sorry, let me do that. Okay, yeah, we do not need this. We're just going to use the feature ID, so we're going to do this. Yeah, so we've actually already defined the model and the layer. Just like we used it in here, we're going to just do the same thing. If you didn't reformat, so if you didn't reformat in here, you just put out the index, then you would have to add on the model and the layer. But we've already done that, so we're not going to have to, which is pretty neat for us. Cool. All right, how are we looking on time? We've got 20 minutes. Perfect amount of time. Okay, right. We probably should write some like error handling in case we don't get a response here, but I'm not going to for the sake of time. So I'm just going to plow on. So this is our data, and we want to get the explanations out. So it's going to be data.get explanations. Oh, sorry about that. This is just us processing this fairly unfriendly JSON. Like I said, you could download it and have a proper scroll through. I recommend you do. It's probably going to help you understand the structure best. But for now, I'm not going to do that because we're a little bit tight on time. And I don't actually think it's that interesting, because basically all we're doing is we're saying, okay, get the explanation which is returned. So Neuronpedia has said, you are interested in this feature. Here is the explanation, and we're gonna get it from the JSON. That's the long and short of it. What I'm actually doing is I'm getting the description. The explanation has got like a whole load of detail, including how the explanation was produced. If you probably should have a look at this, but some of them I think were done by hand by researchers. In fact, I'm almost certain that like a chunk of them were, but also a chunk of them were described by more advanced models, so GPT 3.5. There have been, more recent LLMs, more powerful ones, have been used to annotate SAE results, which is like a nice little use of AI to improve on our understanding of AI. Okay, and now we're going to make. Let's make this slightly more descriptive. We're going to make a dictionary, and it's going to have a whole bunch of things in. And this is where I am going to copy and paste, because otherwise this is going to be really boring. So let me just grab these for us. What we're doing is we're just passing the remaining information. We're going to use the examples. I don't think we're going to use anything else from this. I don't think we will. But there, like you can see here, there are lots of very interesting things. So, for example, with Neuronpedia, it can tell you other tokens which are connected with the feature that you are interested in. And it can also tell you tokens which are the opposite, right? The ones that are completely far away. So the most related and the least related. You might think, maybe the most related, if you put in a feature, a feature which was relating to dogs would be, like German Shepherd or Golden Retriever, and the least related might be cats, right? But actually, no, cats are animals. Animals and dogs are going to be related. The least related would be something like completely different, like very, very different. Often the least related things are like kind of slightly unintelligible tokens, which don't make a ton of sense. Sometimes like grammatical things or whatever. At least that's from my understanding. And my experience of looking at them. I'm sure there's like a better explanation for that. And you can look at histograms for the frequencies of where they all kind of relate, and that's quite an interesting thing to do. So I recommend that. Nice. Okay, so we've got a function, and like always, we're going to run it, and it's going to work. Yay! Now we're going to do a little test. So let's try fetch feature info. Yep. And we're going to say, let's try one of the features that we got from our prompt earlier. And let's just get the explanation, because I don't want to have to look at all of that. And let's see what we get. Mentions of ancient civilizations and artifacts. Wow. So I hope you're all finding this as cool as I have. So the wizard opened the ancient. The thing that it's decided is most relevant, the top feature, is mentions of ancient civilizations and artifacts. That's, I think, really interesting. Like, we can see a very clear connection here in the theme, right? The theme of this is like a wizard, artifacts, and ancient civilizations is like very key to that. And not only that, it's talking explicitly about, I can't remember what the prompt is, but it's talking explicitly about the wizard opening some ancient thing, or possibly a door or something, but like some ancient noun, right? Something which is going to interact with. So this is cool, I think, the fact that it's kind of got like an interesting angle on that. All right, I think we're pretty much there for all of the functions that we need. Nice. So we've got about 10, 15, well, 15 minutes left. What I'm going to say now is we're going to do this little thing related to ngrok. This is like the auth token, I think. And I've got the link open somewhere. You're going to have to make an account with ngrok. It's entirely free. I'm just pulling it up here. Let me drag it down, actually. Okay, cool. Again, like I'm not going to show mine, but you can grab your auth token here, and this just allows you to. ngrok is like a tool which allows you to deploy your projects really easily. So you're going to be able to check out mine in a minute, which I hope is going to be really interesting for you if you haven't managed to code along. And again, we're going to add it in here. So I could copy it. I could make a new secret. I could call it ngrok auth token or something. I mean, I just called it ngrok. That was lazy for me. I should call it something slightly more descriptive. But you can just throw it in here. And then again, make sure you enable notebook access so that you can actually use it. Cool. And then we're going to get on with the Streamlit interface, and then hopefully it will connect all of these different bits which we've been looking at really nicely and clearly for you all in a way that's nice and sensible. So I'm gonna keep on coding while ngrok stuff. Let me send the link. Sorry, I don't think I sent it. Let's have it in the chat. There we go. If you go directly to that link, it's going to have a paddy, and it's going to want you to make an account. It's free to make an account. I recommend just making it along to that and doing that. Here's the link up on the stream. And we're going to do one more little set of installations because I don't think we've done them. Actually, maybe have. Have we installed? Yeah, we have installed. Okay, we've installed Streamlit and ngrok. Okay. So, like I said, ngrok, it just helps us deploy. Because we're working in Colab, we can't just like run it locally as easily. So that's how this is going to work. The first thing that we're going to do is we're going to write the app file. This is going to be an app.py. And paste this in because again, like this is the Streamlit side of things and it's not particularly interesting. I recommend you head along to my notebook. I'm going to share that again. If it loads. Okay, awesome. So you can follow along here if you haven't been already. And yeah, I recommend you just copy and paste this into your own. This is all mostly just formatting, to be honest. Streamlit, if you haven't used it before, is like a really nice and easy way. It's mostly used for like data and like dashboard kind of like visualization style projects. But I love it because I'm not really into the web dev. Controversial maybe in the hackathon world, but and it allows me to produce things really quickly. I've got some some formatting, right? We've got colors. This is actually not dark red anymore. It was dark red, and I decided it looked ugly. It's like a salmon red kind of color. Sorry, my British spelling coming through here. You will have noticed I used some American spellings earlier up, and that's because of sometimes, things like color and stuff, you have to use the American spelling. It breaks my heart, I'm truly patriotic. I love England. I love the UK, but the technical world is in US English, unfortunately. No, I shouldn't say that. I love our American friends. Right, so there's not much to this except we're just making like a little interface. The thing to notice maybe is this is gonna literally just write a file. So if we go here, I don't even know what sample data is here. Okay, this is just data which like Colab has decided to just give us in our file for some reason. But when we run this, it's gonna throw it in here. And this is just all formatting really. You can play around with this and try changing things and see what happens. But I'm going to run that, and you're going to see down here, it's going to say writing app.py, and it's going to throw it down into our file structure. Cool. And then I'm going to make another little code block, and you can also see probably at the top that I've already referenced model utils and SAE utils. And you can see these, and these will be familiar to you because they are functions that we have already written. Oh, didn't mean to do that. These are functions that we've already written. This is our model utils. This is our SAE utils. Remember, our model is used to get the top K tokens, the predictions, and the SAE is used to get the features and interpret the features using Neuronpedia and their API. So we love that. And I'm going to scroll down just a little bit more, and let's make those files. So we need model utils first, and I'm going to copy and paste it again. Most of this, honestly, is stuff that we've already written. It's got a lot more comments on, so it might look slightly different to the one that we did earlier, but when I was planning this, wrote some comments to make it a little bit clearer. So yeah, I mean, all that we're doing really here is doing the imports and like as we've already done and defining the function. So there's nothing new in particular, at least. And we're writing again. It's going to pop down there. We'll just let it do that. Awesome stuff. Okay, I hope this is all still something you're able to keep up with. And I'm going to copy in the final one. You can see this is written down now. It's going to be SAE utils. I'm going to run that, and while I run it, I'm going to explain it. So again, we've got our fetch feature info. We've got our get features. This has actually got steps nicely written out, but the numbers are wrong. It's got some explanations. The reason the numbers are wrong is because I spent some time playing around with this function to get it how I wanted it. I think the comments are all accurate though. I just sometimes don't update my comments. Bad habit. I know, bad habit. Yeah, so all we're doing again is like defining these functions to be called in the main app. So these are utils, right? And you can see here we do the normal loading of the SAE, pre-trained in the same way as before. The only thing to point out here that's different, and I really want to highlight this, is to get the API key, you can no longer access secrets because when the app is running, it needs to interact with your OS. So I've imported OS up here, and instead of using secrets, like we've already got the constant defined. So this should all just work. No, it doesn't. No, we're going to make it work in a second, actually. I'm jumping ahead. But yeah, these are just the functions that we've written already. You'll be familiar with them, hopefully. Okay, cool. And now we're going to deploy it. Yeah, just checking the time. We've got 10 minutes. So we've got loads of time to deploy it and have a little play around with it. And this is the moment which we're kind of all waiting for, the lovely moment when it hopefully works and is pretty, because we've got some things working, which I think hopefully are interesting to you. But it's not satisfying to use at the moment. Certainly, you couldn't use it in like a hackathon project just in the IDE like this. So I'm just going to delete this. I've already set us up here. So what I'm doing, like this is what I was saying earlier. I'm setting an environment variable even in the OS. This is I'm just going to pop this up here. Let's make things a little bit neater. I'm getting the auth token from ngrok, which we set over here. Make sure again to use the right name. And then, yeah, I'm setting our Neuronpedia API key in the environment, in the OS environment. This is so that the app can actually access it. Pardon me. It cannot access secrets when it's deployed. So yeah, like I've written here, it's already loaded via secrets. In theory, then we can just deploy it using ngrok. Ngrok is like this neat tool which just allows us to run something on a URL. The kind of goal here was to start a tunnel, and so we could run it locally, but it ended up actually just being easier to run it at a public URL. So I mean, that kind of works for us because you can now go and check out mine once I run this. If you spam it, it might stop working, but probably won't. Okay, this is brilliant news. Knew it was too good to be true. Okay, so what's happening now is I'm already running an ngrok session. I'm running it on a separate window, which I was doing my little tests in, and hopefully I've just killed it in either window. Hopefully this is going to run out. Yes, okay. Just so you all know, if you run this 3 times, it won't automatically kill the previous ones. Maybe it would if you restarted the runtime, but it probably wouldn't by default. So you can, with this little command here, kill all ngrok. That will end all of the existing tunnels. And now we have this link, and I'm going to click it. Hopefully it's going to work. And so this is going to be all of the stuff that we've already done in functions. So yeah, this is just normal for ngrok. Suffer free through ngrok. Yay. And hopefully we're going to have this lovely Streamlit page. I haven't tried it on my laptop yet to see how it formats. So this is the moment of truth. It's loading. This is okay. It's doing some thinking. I also don't know how this would format on mobile. So your results that you get might vary. Okay, cool. Okay, so we've got a little writing space. This is our interpretable AI writing assistant. This is kind of what I was saying earlier. I don't know what this is linking to. Oh, neat. I didn't know it did that. Yeah, this is Streamlit being awesome. So all of this, I mean, it looks, in my opinion, pretty nice. This is Streamlit being gorgeous. So this is our little prompt. We actually set that as like the little default text in app.py. Wherever app.py is here. Yes, so this is our placeholder text, right? But let's start writing. Let's say the wizard opened the ancient, and it's going to be book because we've already seen it. And look, these are the percentages that we worked at earlier. This is from our top K tokens function. Neat. This is formatted. It formats slightly nicer on a bigger screen, to be honest. But these down here now. So these down here. So these up here, sorry, these are the predictions. So it thinks the wizard opened the ancient book, or the wizard opened the ancient door, or the wizard opened the ancient scroll, is kind of what it's predicting. These percentages might look low, by the way. I didn't say this earlier. They might look low. This is just because there's like a lot of different words that it could be. They will add up to 100. And then it's telling us the activated features, the top ones. And these are the IDs that we extracted. And this is the one that we actually fetched with our little manual API request in Colab. Mentions of ancient civilizations and artifacts. This one is phrases related to opening or closing actions. So, well, we've got opened in there. That makes perfect sense. Phrases related to physical actions and settings. So again, like opening, it being physical, this kind of makes sense, right? And we can see how it's gone. Okay, it's something ancient, maybe artifact related, and it's opening. It's something that can be opened. It's physical. So can a book be opened? Yeah. Is it physical? Yeah. Is it an artifact? Debatably. An ancient book, maybe. An ancient door, an ancient scroll. Yeah, these all work, right? And so the goal for this project was to build an interpretable AI writing assistant. So it didn't just give you predictions, but it kind of explained them. You could understand them. And I think we've done that, which is really cool. We can see examples. So these are also coming from that JSON. We didn't explore them explicitly earlier. And these don't format so nicely. We could maybe do some work here. But these are all individual examples which also have high activations on this feature. So mentions of ancient civilizations and artifacts. What is this one? It's talking about ancient aliens, precursor races. Yeah. And then we go to the next one, the Ark, ancient Egyptian texts. The next one, ancient super. You can see here some of the tokens are slightly strange. This maybe is because of how it's formatted, or maybe it was like some unusual text. This here, you can see it's clearly like scraped from some social media sites, but we've also got an ancient and then ring as well. So this is again kind of like connecting up with the artifacts and the ancient bits nicely. Compelling civilization, ancient civilizations. So we can see like these are other examples of texts which activate strongly on this feature, and we could check this for any of them. I think that's pretty neat, and we could use this as our writing tool. So we could keep going. The wizard opened the ancient book, and inside he was shocked to find. And then it's going to predict the next things, and in this case, it's mostly stop words. And this is, I mean, I think this is awesome. I didn't plan this example, but the top feature is instances of the word find followed by various contexts and subjects, which is exactly what we've got. Action verbs related to observing. And then, oh, this is interesting. So phrases related to the Harry Potter series. Again, like Wizard open his ancient book. This is pretty Harry Potter. Sure. I thought maybe it would be fun if someone wants to suggest something, I can pop it in here. You can also just like check out the app live. I'll post the link. And then I think I'll wrap up pretty soon. But yeah, if someone has any suggestions for something they'd like to see me type in here, I'm happy to take suggestions. But yeah, the idea is that we built this tool that, you know, when you can't find a word, it will predict some words for you and tell you why. We could also search like short stories. Oh, okay, let's try that out. We've got a suggestion from the chat. The wizard. So this is probably a good point to raise, and I'm glad that someone's found one that gives a weird result. The wizard saw a magic circle. Gives some strange activated features. It does. Okay, interesting. Instances of the word it being emphasized in a sentence. Oh, yeah. So that doesn't make much sense. Phrases related to the company Square Enix. Mentions of activities or events involving people being watched or observed. So I guess that one makes sense, right? Events involving people being watched or observed. Yeah, there's an element of like observing here. A magic circle is an event, sure. Instances of the word it being emphasized in sentences. That doesn't make much sense. Neither does this one. I don't really know who Square Enix are. It seems mostly they just kind of activate on explicit references. So yeah, that's slightly unusual. But I mean, I guess the point is that it's not going to be perfect, right? So you could test how reliable an SAE is at extracting the features from a model. In this case, this might be the SAE not perfectly representing the activations very well. It might be that in a different layer, if we didn't use 11, maybe we used, I don't know, 6, 7, 9. If we tried different layers or some combination of layers, maybe we could get better results. But yeah, I think this is like a really good way to highlight that actually this is not a perfect tool. It's not like we are deterministically working out the inner workings of an AI. We are using another model to try and understand. We're literally modeling it, right? So it's not perfect. There are data sets that you can use to test how good SAEs are. There might be a better one for GPT-2. I think this is one of the better ones that I know of, but there might be a better one. Yeah, so I thought I would head along to a little short story website if this loads. And let's just like copy and paste a short story. Let's see if we got anything. Let's just copy it. Oh, is it gonna let me copy it? Oh, I was really hoping. Oh, there we go. Okay, let's just. Yeah, this is very coincidentally something to do with being British. I am not affiliated with this website, by the way. This is completely just something I found off the internet. We're just going to test it. All rights go to the author and so on. So this might be interesting because it's got some unusual characters. Let's just delete a little bit and then see what happens. Okay. So it's just predicting punctuation, but it's saying, okay, weather-related terms, financial transaction methods. I don't really know where it's getting that from. Phrases related to conversations or exchanges. Yeah, communicating exclusively. That makes sense. Let's delete something else. Let's go down to maybe here. The restaurant fell. Let's see what we get. Okay, that's really cool. So the restaurant fell silent is what we're kind of expecting. Based on that's what it was originally here in the short story. That's cool. It could also be the restaurant fell into, let's see what it thinks after that. And then I'm going to wrap up. We're out of time. Into silence. So yeah, it's predicting pretty well. Crisis or negative states. Instance of the phrase fall in love. Moving on, transitioning. So these all make sense. We had a question, a really good question. What happens if you add a space? Well, a space is a token, so it's gonna have a tantrum. It's gonna get really confused. It's gonna say, it's a special character, mentions of French names, locations. It's getting a little bit disturbed, just because it's like, oh, like why is there a space here? I don't know what Vern is. But yeah. So if you add extra tokens, like similarly, if I added like some really weird like symbol, it's gonna get very confused, right? Email addresses. That's just because it doesn't recognize spaces in the normal way. This is potentially how it starts and ends prompts because of how it tokenizes them. So that's a really interesting point to raise. I recommend like doing some more reading on that, having a play about. But for now, we're done. I think I'm overrunning slightly. I hope whoever's after me isn't upset. I don't know what the next stream is, but I recommend checking it out. As a little reminder, please do check in. You get points. It makes me happy if you check in. And everyone wants a happy Quinn. This is the check-in link. All right, I'm just going to throw that up on the screen. And what else is there to say? Oh, if you want to give me feedback, I really appreciate having feedback. I always want to do better for you all. I want to know what you want to see more of. I want to know what you love. So yeah, fill out this form. You can tell us what's good, what you'd like to see more of. I think that's pretty much it. I hope. Ooh, I'm gonna do some strange things there. Let's not do that. Too many windows open. Yeah, I hope you've all had fun. Feel free to check out the notebook. I'll leave it open for you to copy and paste from and view. And yeah, happy hacking. Thank you very much for coming. And I'll leave it there. Thank you all. Goodbye.